Hey everyone, let's talk functional groups for a little bit. As you know, functional groups are atoms or groups of atoms with characteristic chemical and physical properties. And these functional groups can be attached onto all kinds of different molecules. On the back of your periodic table, you have a chart of functional groups, and they're split into 3 different sections. Here's the first section. These are functional groups that are made of hydrocarbons. Now the first thing you see on this chart is an alkane, but an alkane isn't actually a functional group. That's just a carbon chain with all single bonds between the carbons. So that's why you see a dash there for functional group. But then we have an alkene, an alkyne, and an aromatic compound. So alkenes have double bonds between carbons. Alkynes have triple bonds between carbons. And aromatic compounds, for our sake, we'll just say are compounds that contain a benzene ring, which is a 6-carbon ring, looks like a hexagon, with alternating double bonds. The second set of functional groups are compounds that contain a carbon heteroatom single bond. Remember, a heteroatom is an element other than carbon or hydrogen, such as oxygen or a halogen. So you can see here we have an alkyl halide. That's a carbon bonded to a halogen, like fluorine, chlorine, bromine, or iodine. We have an alcohol, very common functional group. That's where you have an OH group bonded to a carbon chain. Then there's an ether. An ether kind of looks like an alcohol because you have a single bonded oxygen. The difference is that oxygen does not have a hydrogen attached to it. That oxygen is between 2 carbons. Next we have an amine. An amine is fairly recognizable because it has a nitrogen in it. Now, that nitrogen has to be bonded to a carbon. It could have 2 hydrogens on it, it could have 1 hydrogen on it, it could have no hydrogens on it. Just look for a nitrogen bonded to a carbon and that'll be an amine. These are all functional groups that contain a carbonyl group. That's a C double bond O group. The first 2 are fairly similar to each other, the aldehyde and the ketone, because they have a C double bond O, C double bond O. The difference is the aldehyde, that carbonyl group, is on the first carbon of the compound, so there's a hydrogen attached to that same compound. Sorry, there's a hydrogen attached to that same carbon. I always just kind of remember the letter A starts the alphabet, the C double bond O starts the compound. In a ketone, that carbonyl carbon will be bonded to carbons on either side. Now these 2 are kind of a pair, a carboxylic acid and an ester, because they have a double bond oxygen, but the carbon right there is also single bonded to another oxygen. See how those 2 are similar? Now they're different in that in a carboxylic acid, that single bonded oxygen is also bonded to a hydrogen, and in ester it's not. So in a carboxylic acid, this group will be at the end of the molecule, and in an ester, this group will be in the middle. Finally, we have an amide, which is similar to an amine in that it has a nitrogen. The difference is that nitrogen is bonded to a carbonyl carbon, or a C double bond O. My suggestion now is that you stop this video, try these questions on your own, you're identifying functional groups in these molecules, and then restart the video and check your work. In this first molecule, we see a ketone, that's C double bond O with C's on either side. Make sure you're spelling ketone correctly, there's no Y in it. In the second compound, there's 2 ether groups. See the O with C's on either side? And there's also an alkene, 2 alkene groups because of the double bond. In this last one, there's a lot of things going on, so I'll do one thing at a time. There's an amine group, see the N, C double bond O, and C double bond O. There's a couple of amide groups, see the N bonded to carbons, N bonded to carbon. Lastly, there's an alkene because of that C double bond O. Again, you might want to try these first, stop the video, and then restart it to see the answers. In this first problem, do you see that CHO group? There's not a lot of hydrogens there, and the only way to draw this in such a way that carbon gets 4 bonds is to have a double bond O there. That makes this group an aldehyde. Be careful not to call this a benzene ring. There's no double bonds, so there's only 1 functional group here. This next example, we have a C double bond O with C's on either side. That's a ketone. Here we have that C double bond O, that carbonyl group, but that carbon's also bonded to a nitrogen, making this an amide. These bottom 2 are kind of similar in that they both have this CO2 group here, Whenever you see two oxygens like that, one will be double bonded and one will be single bonded. This bottom one also has a hydrogen attached to that oxygen, making this a carboxylic acid. This one does not have the hydrogen, it has a carbon instead, making this an ester. With a little more practice, you'll have your functional groups down pat.